We'll start off by taking a look inside the atom. At the center of every atom, there is a small positive nucleus. This is orbited by negative electrons, which are grouped in shells. While this is the most commonly used model of the atom, it's important to remember that this is not what an atom actually looks like. Let's take a closer look inside the nucleus now. Inside, we have two types of subatomic particle: neutrally charged neutrons and positively charged protons. These positively charged protons give the nucleus its overall positive charge. If you're struggling to remember the relative charges of these two subatomic particles, the alliteration between their charge and names might help. Neutrons are neutrally charged, and protons are positively charged. Protons, neutrons, and electrons are all incredibly small. Their masses and charges are also very small. We describe the masses and charges relative to each other. That's to avoid writing 27 zeros each time if we were to use kilograms. You need to know the relative masses and charges for neutrons, protons, and electrons. Neutrons have no relative charge. Protons, which are positive, have a relative charge of positive 1, and electrons, which are negative, have a relative charge of negative 1. Neutrons and protons both have a relative mass of 1. The mass of an electron, however, is 2,000 times smaller than these. You won't need to know the relative mass of an electron in your exam, and you can just use the term negligible. This means it's so small that it's unimportant. In an atom, the number of protons and electrons are equal. We know this because atoms have an overall neutral charge. If this weren't the case, then every atom would repel each other, and everything you see around you wouldn't exist. Thankfully, that doesn't happen. We know that protons have a charge of positive 1, and that electrons have a charge of negative 1. So, for atoms to be neutral, the number of protons must equal the number of electrons, so their charges cancel out to 0. When the number of electrons is not equal to the number of protons, we call that atom an ion. In this video today we have covered that the nucleus is positive and contains protons and neutrons. Protons, neutrons, and electrons all have different relative masses and charges. You need to be able to recall these in an exam, apart from the relative mass of an electron, which we can describe as negligible. And finally, in a neutral atom, the number of protons is equal to the number of electrons. Don't forget to check out all our other fantastic revision resources at Save My Exams.
Okay, I've taken it from Save My Exam. If you want the notes, let me know. I will send you the notes. Okay, let us start the lecture. Usually, we will have about half an hour lecture. Then we have about 50 minutes break. The reason for 50 minutes break is because they have to convert the recording and then I have to save it. Then I will send you the next Zoom Okay with that?
Okay.
Okay with that?
Okay. It's okay.
So this is the syllabus. You're supposed to describe the structure of the atom in terms of positive charged nucleus, negatively charged electron in orbit around the nucleus. Know how atoms may form positive ions by losing electron or form negative ions by gaining electron. Describe how the scattering of alpha particle by a thin sheet of metal supports the nuclear model of the atom by providing evidence for small nucleus surrounded by mostly empty space. Nucleus containing most of the mass of the atom. Nucleus that is positively charged. Okay, so that's basically where I get it. That's your textbook. this website that I got the notes from, basically they follow the syllabus lah. So your textbook is mainly for IGCSE and O level lah. So textbook usually will not conform exactly to the syllabus lah. Sometimes they add it extra so that those students who are inquisitive, who want to know more, can go and read up more. Lor. That's the whole idea of textbook. So not everything in the textbook are required for your exam lah. Okay, atomic structure. Right? An atom, a small positive nucleus surrounded by negative electron. Positive nucleus surrounded by negative electron. That's the old picture lah. Atoms are building blocks of all matter. Right? Very small. 1 × 10 to the power minus 10 meter. Right? This means that about 100 million atoms could fit side by side across your thumbnail. Just imagine that. So huge number. Atoms have a tiny dense nucleus. So it means that all the mass are in the nucleus at the center with electrons orbiting around the nucleus. That's the old picture lah. Okay, you can use your chemistry picture also. This is the old picture. Like the solar system lah. The radius of nucleus is about 100,000 times smaller than the whole atom. Right? That's the size of the atom. Diameter 10 to the power minus 10 meter. Nucleus is 10 to the power minus 15 meter. 100,000 times smaller. They consist of small, dense, positively charged nuclei surrounded by negative charged electron. Okay, so we will look into the experiment in a while to see how we get this picture. Right? That is the picture. There's your plum pudding. Right? The plum is your electron. And then this is the picture they have it during Rutherford's time. Right? It's called plum pudding. Okay, so you have negative electron balanced by positive charge. So in 1909, a group of scientists were investigating the plum pudding model. This is called the plum pudding model. Physicist Ernest Rutherford was instructing 2 of his students, Hans Geiger and Ernest Marsden, to carry out the experiment. Right? So he is probably the lecturer, the professor or the supervisor, and then his students interested to do a PhD under him or do a research under him, so he guide them. This involved the scattering of alpha particle by a sheet of thin metal. Support the nuclear model of the atom. Okay, let's see how the experiments support the nuclear model of the atom. Okay. You don't need to know really the exact experiment, but this is how the experiment look like. This is the source of, in case you want to follow your book, that's the page from your textbook, 242.
Yeah, I know. I'm on the page now.
Okay, so this is probably carried out in a dark room. And then this is an alpha particle from the source, right, directed at a thin gold foil. We try to make it thin so that, if possible, we have 1 atom thin, but that's not possible. So usually it will be a few atoms thin. Then this is your screen, right? Circular fluorescent screen. Fluorescent, it means that where the alpha strike the screen, you will see tiny spark of light called scintillation. So a beam of alpha particle. What's alpha particle? Helium nucleus. That means it has lost 2 electrons. That's how we write it. Helium 2+, lost 2 electrons, or helium ions. were directed at a thin gold foil. This is your thin gold foil. This is your source of alpha particle. That's your screen. So the person will have to, not like us, we got detector to count for us. They have to sit down quietly and patiently count all these tiny sparks. They expected the alpha particle to travel through the gold foil. Right? They expect all of them to be like that. Go through directly. They do not expect all like that on the side there, and then all rebounds back. And maybe change direction a small amount, just like that. Small amount of change direction, that's all, not like here so much. Instead, they discover that most of the alpha particle pass straight through this one. Very little change in direction, most of them. Some of the alpha particle change direction, but continue through the foil, right? Change direction, or we call deflected. These are some. A few of the particles bounce back off the gold foil. Yeah, that one rebounds. Right? That means all these are less than 90 degrees. These are more than 90 degrees. Rebounds back. So when we have the observation, then we must try to explain it. The bouncing back could not be explained by plum pudding model. So a new model had to be created. Right? We started off with some ideas. We call it model. And if our experiment carry out, we cannot explain the model cannot explain it, then it's no good. Right? We develop another model, another idea. So this is the first evidence of the structure of the atom. How does the atom look like? Okay, there are three types. A, more or less straight through. B, deflected at an angle. C, rebounds. So when alpha particles are fired at a thin gold foil, most of them go straight through. This is A. Very small number bounce back. Right? Very small number. This is very few. This is some. So let's summarize it again. When alpha particles are fired at a thin piece of gold foil, majority of them go straight through. That's your A. This happens because the atom is mainly empty space. Between this nucleus and this nucleus, there's a lot of empty space there. Right? So that means this alpha is not affected by the positive nucleus. Right? So majority of them go straight through. This happens because the atom is mainly empty space. Some are deflected through small angle. This happens because the positive alpha particles are repelled by the positive nucleus, which contain most of the mass. Right? What is happening? This is alpha coming in. Remember, alpha is too positively charged. The nucleus is positively charged. So depend on how close the positive charge is to the nucleus, it will be deflected. If it's nearer, it deflected more. If it's further, deflected less. Right? That's for this case there. A very small number, we call it few, are deflected backwards. That's your C part, this part.
Does
This is
it mean
because
like
the nucleus is extremely small.
does it mean like it's like its direction is depends on just like where it went?
Say a
Is
bit
it straight
louder.
line?
Oh,
Does it
straight
mean
line like
like
A
it
lah.
depends
A will be main, a
a
lot of
straight
them.
line,
Majority will
or
be
it
straight
just
line,
like
no?
touched the, yeah, it depends on, is it go straight line or touched
Depend
the
on where the
nucleus deflected?
particle is. Most of it
Okay.
will go straight line. But those who go near the nucleus will be deflected. Those that directly collide with the nucleus will be deflected back, rebounds. Okay
Thank
with that?
you. Yes.
Okay, stop me if you need to ask question. So what is an ion? An ion is an electrically charged atom or a group of atoms formed by loose or gain electron. So if the atom lose an electron, it's an ion. If the atom gain an electron, it's also an ion. A stable atom normally electrically neutral, right? A stable atom is electrically neutral. This means that it has the same number of proton is positive charge, and electron, negative charge. That means it has the same number of proton and electron. So you can use your idea of chemistry to help you. Right? This is 6 proton, 6 neutron, 6 electron. Neutral atom. If you have an extra electron, then it's an ion. Right? This is more electron and proton. If it's positively charged, it has 6 proton, 6 neutron, 5 electron. It has lose 1 electron. Right? That's the difference between atoms and ions. Positive ions are therefore formed when atoms lose electron. Negative ions are therefore formed when atoms gain electron. Okay, no question. Okay, the exam tip, you may hear the term net charge. This just means overall charge of the atom. That's all. Whether it's positively charged or negatively charged. If an atom has 5 proton, 5 neutron, and 6 electron, it has a net negative charge because it's a negative ion. That means it has more electron and proton. Remember, which way around the charges are by proton being positive, right? The easiest way to remember is proton, P. Positive is also P, right? Associate them. Okay, afterward, during the break, you can try this question on page 243. Make a note of that. Right, you can have a look at that. Okay, let's now look at the nucleus. I can read the syllabus. Page 225. You can use your chemistry, the idea of atom. Right? That's your nucleus. That's your electron. That's your electron. Right? Neutron is green in color. So there are 4 neutron, 3 proton. Right? Proton is red in color. Right? This is called the nuclear model. The structure of atom is made up of positively charged nucleus. Nucleus is positively charged. At the center, make up protons and neutrons. And then negative charged electron in orbit around the nucleus. Protons have positive charge, while neutron has no charge. Proton, positive charge. Neutron, no charge. So overall, the nucleus is positively charged. Be careful with terminology. Atom means nucleus. Nucleus means proton and neutron and electron. Nucleus means proton and neutron only at the center of the atom. Okay, we will now introduce some term. Proton number. That's called Z. Number of proton in an atom is called the proton number. It can also be called atomic number. Alternative name, atomic number. Right? So proton number Z or atomic number. Elements in the periodic table are ordered by their atomic number. Right? By the proton number, how many protons they have. They put in order there. Therefore, the number of proton determine which element is an atom. Right? So the proton is the one that determines which element is the atom. Atomic number of a particular element is always the same. Right? Hydrogen atomic number 1. What do you think this atom is? Can you guess? 3 proton. You want to guess?
Wait, I look at the periodic table.
Can
Is it
guess?
helium
No,
or hydrogen?
helium is 2 only. This is lithium. Lithium.
Oh,
You don't need to
alright,
remember
good
lah.
one. Good
But
one.
if you want to know, you can look up
Suddenly
the
forgot.
periodic
Suddenly
table.
forgot. Yeah, it's
Right?
from
For
the
example, hydrogen.
group one.
Okay or not?
Yeah, okay.
For example, right, proton number Z. Hydrogen has a atomic number of 1. It has only 1 proton. Sodium has an atomic number of 11. It has 11 proton. Uranium has an atomic number of 92. That's 92 proton. Atomic number is always equal to the number of electron. So when the atomic number itself can tell you the number of proton, but in a neutral atom, it's the same as the number of electron. Right? That's your periodic table. Right? S1, S2, S3, 4 is beryllium. No? Okay, next term is A, nucleon number. What is it? Total number of particles in the nucleus of an atom is called a nucleon number or mass number. Right? Nucleon number or mass number. A, total number of particles in the nucleus. Mass number is the number of proton and neutron. Right? The number of proton and neutron. Number of neutron can be found by subtracting the atomic number from the mass number. Right? There's if you write a number of neutron, nucleon number A minus proton number Z. So you prefer memorize it in formula, that's the formula. Right? Number of neutron, atomic number, nucleon number minus your proton number. And that one you need you to memorize. For example, if sodium has a mass number of 23 and atomic number of 11, then the number of neutron will be 23 minus 11 is 12. No? At exam T, you may have noticed that the number of electron is not part of the mass number. Any idea?
The mass of the electron is negligible.
Good. Mass of the electron is negligible, very small compared to the proton and neutron. This is because electron have a tiny mass compared to neutron and proton. We say their mass is negligible when compared to particles in the nucleus. Right? We can compare to proton and neutron. The mass of electron is negligible. Right? We introduce a nuclide notation. A nuclide is a group of atoms containing the same number of proton and neutron. Right? So we have atom, we have element. So in 5 minutes time, I will stop. For example, 5 atoms of oxygen are all the same nuclide, but are 5 different atoms. Okay, so we represent it with X. X is a chemical symbol. And then Z, that is a proton number. A is your neutron number. Right, so you have to memorize that. Atomic symbol are written. Don't worry about this one. This is to tell you that this notation is called nuclide notation or XZXA notation. Right? If you look at internet, some people will write differently. We'll put the A and Z in front here. Okay, so we are using the nuclide notation. Right? So nucleon number or mass number, proton number or atomic number. A represent the nucleon number or mass number. Z represent the proton or atomic number. Right? That means the number of proton, no? The number of neutron and proton is A, no? And there's a chemical symbol. In chemistry, the nucleon number is referred to as the mass number, and the proton number is atomic number. Periodic table is ordered by atomic number, right? Ordered by that. Example of atomic number, right? That's the mass number. That's the atomic number. When given an atomic symbol, you can figure out the total number of proton, neutron, electron in the atom. So how many proton are there in lithium?
3.
How many proton are there in lithium?
3.
3, okay. How about electron?
Both of them are the same, so it's also 3. The
How many?
numbers. 3.
How about number of neutron?
4.
4. 7 minus 3 is 4, correct? Good. Right? Number of proton is the proton number. Number of electron is the same. They are the same. Neutron, we just subtract. So the term nucleon is used to mean the particle in the nucleus. Nucleon means the particle is in the nucleus. They can either be a proton or a neutron. The term nuclide, same lah. We are associated with nucleus. It's used to refer to a nucleus with a specific combination of proton and neutron. Right? So there is a nuclide. Okay, try this question. What is the answer? Element symbol for gold, AU. How many proton, neutron, and electron are there in gold
A.
atom? What's the answer?
A.
R.
A. Wait. D.
Donkey, is it?
Yes, donkey.
Okay, you're right. They must have the same number of proton and electron, no? And then 197 minus 79, no? 118. Good. Isotopes. Right? Hydrogen has 3 isotopes, each with a different number of neutron. Right? This one, hydrogen, has 1 proton only, 1 electron. Deuterium has 1 proton and 1 neutron. It still has 1 electron. Right? The proton and the electron are always the same for neutral atom. Tritium has 1 proton, 1 electron, 2 neutron. Okay, so although the number of proton in the particular element is always the same, the number of neutron can be different. Right? In an atom, in an element, the proton is always the same, but the nucleus can have 1 neutron extra or 2 neutron extra. Isotopes are atoms of the same element that have an equal number of proton but different number of neutron. Okay, so isotopes, you need to remember what is isotopes. So this means that each element can have more than 1 isotope. Isotopes tend to be more unstable due to imbalance of proton and neutron. Right? If you have too many protons or too many neutrons, they can be unstable. Right? This is stable. This is stable. This also is stable. Tritium is less stable. Right? These are isotopes of hydrogen. Isotopes occur naturally, but some are more rare than others. This is common now. This is rare lah. For example, about 2 in every 10,000 hydrogen atom is deuterium, right? Very rare. Tritium is even rare, even more rare. 1 in every billion hydrogen atom. Right? To show you it's unstable. Okay, what's the answer for this one? Which of the following elements are isotopes of each other?
I'll take a look.
What's the answer?
Um, A.
No.
A.
Isotopes must have the same number of Z. This one, 92.
Also, it will be B. It will be B
92.
in that case.
This is not. This is
Okay.
different
That
element.
one is iron, right? That one is iron.
This one is uranium. This is chlorine. This one, I'm not sure what is this.
Okay.
You have to check the periodic table. This one is carbon. This one
Okay.
is something else. Oxygen. Okay.
Okay. Yes.
Answer is B. I think we take 15 minutes off before we start a new topic. So I'll stop the share. You can do the question that I've given you. Okay, I see you in 15 minutes time while I have to stop it. And then this one will take a while to record lah. To convert it to video lah. Okay, see you about 15 minutes time.